We are happy to be back with another informative unit. If you want to add more to your knowledge of power system, this is what you want to follow. Before starting with our unit 2, please make sure that you have watched and completed the first unit. That way, you will be very much comfortable with the content of unit 2. Nuclear power station. The generating station where nuclear energy is converted into electrical energy is called nuclear power plant. A nuclear power plant uses uranium as fuel for generation of electrical energy. Schematic arrangement of nuclear power plant and its working principle. Uranium are used as fuel and are subjected to the reactor. They heat energy obtained as steam at high temperature and pressure according to the famous formula that E is equal to mc square. The obtained steam energy is used to run steam turbine, which in turn will convert the steam energy into electrical energy. As usual, the alternator is coupled to the turbines. Alternator will convert mechanical energy into electrical energy. With the help of nuclear power plant, huge amount of electrical energy can be produced from comparatively smaller amount of nuclear energy. For example, if we use 2 kg of uranium, this will be equal to 9,000 kg of high degree coal. In order to best understand the working principle and schematic arrangement of nuclear power plant, the whole plant is divided into main 4 parts. 1. Nuclear reactor, heat exchanger, steam turbine, and alternator. First, nuclear reactor. The apparatus in which nuclear fuel is subjected to nuclear fission is called nuclear reactor. The main job of nuclear reactor is to control the chain reaction. What do we mean by chain reaction? Nuclear fission is done by bombarding uranium nuclei with slow-moving neutrons. This splits the uranium nuclei with the release of large quantity of energy and emission of neutrons. These fission neutrons causes further fission. If this fission continues, then in a very short time, a huge amount of energy will be released, which may cause explosion. This is known as explosive chain reaction. But in a reactor, controlled chain reaction is allowed. This is done by systematically removing the fission neutrons from the reactor. The greater the number of fission neutrons removed, the lesser is the intensity of energy released. If the chain reaction is not controlled, the result will be an explosion due to the fast increase in energy released. A nuclear reactor is a cylinder vessel and houses fuel rods of uranium, moderator, and control rod. The fuel rod consists of the fission material and releases huge amount of energy when bombarded with slow-moving neutrons. The moderator consists of graphite rods which encloses the fuel rod. The moderator slows down the neutrons before they bombard the fuel rod. The control rod are of cadmium and are inserted into the reactor. Cadmium is strong neutron absorber and thus regulates the supply of neutrons for fission. Heat exchanger. The coolant gives up heat to a heat exchanger, which is utilized in rising the steam. After giving up heat, the coolant is again fed to the reactor. Steam turbine. The steam produced in heat exchanger is led to steam turbine through a valve. After doing a useful work in turbine, the steam is exhausted to condenser. The condenser condenses the steam, which is fed to the heat exchanger through fed water pump. Alternator. As other power plants, usually turbine is coupled with the alternator. The steam turbine drives the alternator, which converts mechanical energy into electrical energy. The output from the alternator is delivered to the bus bar through transformer, circuit breakers, and isolators. Site selection factors. First, availability of water. As for the cooling purpose of the nuclear power plant, water presence is of very high importance. Therefore, the plant should be located near the place where a huge amount of water is available across river or by seaside. Disposal of waste. After complete process of nuclear fission, a huge amount of waste is produced, which is generally radioactive and must be disposed of properly to avoid health hazards. The waste should either be buried in deep trench or disposed of in a sea quite away from the seashore. Distance from populated area. The site selected for nuclear power plant should be quite away from the population area, and that is due to the radioactive material presence in nuclear power plant. A huge dam may be constructed in order to avoid the spread of radioactive substance due to wind or waterways. Transportation facilities. The site selected for nuclear power plants should be in such a place where transportation facility is available for the movement of heavy equipment and workers. Nearness to the load center. Cost and type of the land. Advantages and disadvantages of nuclear power plant. The advantages of a nuclear power plants are: fuel requirement is small, lesser space is required for building or erecting the nuclear power plant. Its running cost is low, as we have said that 2 kg of uranium equals to 9 kg of high degree coal. Reliability insurance. Generation of more electrical energy from lesser amount of nuclear energy. Disadvantages. The disadvantages of a nuclear power plant is: fuel is expensive, which are uranium, hard to recover, high capital cost, causes radioactive danger, and high maintenance charges.